Hi children, welcome back to the maths class. Actually we are in chapter 12, but now I am going to teach chapter 7 coordinate geometry. That chapter 12 we will see in the next week. Okay, so coordinate geometry is not a new chapter for you. You know very well. In standard 9th also you have learned this coordinate geometry. So now, what is the difference between that 9th standard coordinate geometry and this year 10th coordinate geometry? Let me explain first. In 9th standard coordinate geometry, you have studied about that Cartesian plane, the introduction of Cartesian plane. What is mean by Cartesian plane? Then how to plot the points in the Cartesian plane. You have learned this. This year we are going to study about distance formula, section formula and area of the triangle. So in that these three are the subdivision of coordinate geometry. In that three division, the third one, area of the triangle, was removed in the syllabus due to lockdown. You know very well, each and every chapter some portions are deleted portions. So in this coordinate geometry, the deleted portion is area of the triangle. So only two concepts. One is distance formula, another one is section formula. So first let me explain what is mean by distance formula. Before explaining this, let me ask one question. You just recall your previous knowledge. Why we are saying that plane as a Cartesian plane? There is another name also, that is XY plane. But why we are calling that as a Cartesian plane? Can you say the answer? Because that how to find one position of one particular object. This was firstly the mathematician René Descartes. He only found. That is why the XY plane, we are calling that as a Cartesian plane. Descartes, his name is. Okay. This is the information they have given in your 9th standard book only. Once upon a time, when he was lying on the bed, he thought how to, suppose one lamp. If you are keeping one place on the table, if suppose we are keeping one lamp, how to describe the position of a lamp from vertically or horizontally. Like that, he was thinking and lying on the bed. That time only the idea of this concept was framed by him. First, he has named it as XY plane. Later, to honor that mathematician, nowadays it is known as Cartesian plane. So in that Cartesian plane, there are two lines. You know very well, one is vertical line, another one is horizontal line. Yes, what is the line of the horizontal line? Yes, it is x-axis, and the vertical line is called y-axis. The meeting point of both x and y axis is called origin. Okay, what is the coordinates? So now let me explain about this distance. So this distance formula is helping to find the distance between any two points if the coordinates, if we know. Okay, for example, see here, the length of the line segment joining A and B is the distance between 2 points. Suppose the coordinates of A is x1, y1 and coordinates of B is x2, y2 can be calculated as x2 minus x1 the whole square plus y2 minus y1 the whole square. This is known as distance formula. The x2 minus x1 the whole square can be written as x1 minus x2 the whole square also. Why? Because 2 minus 4 is equal to minus 2. 4 minus 2 plus 2. Whether it is minus 2 or plus 2, while squaring, it is going to give positive number only. You know very well that square of any number, it may be negative integer or positive integer, it's a positive number only. That is why this distance formula we can write in two ways. We can write x1 minus root of x1 minus x2 the whole square plus y1 minus y2 the whole square, or root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, this is distance formula. To find the distance between 2 points if the coordinates of the point known. Okay, then sometimes if the distance from the origin, that means out of the 2 points, 1 point is origin coordinate is 0, 0. From the origin, if you want to find the distance means, distance of the another point means, the formula is root of x square plus y square. This two formulas we can use as per the sums. Whenever you are seeing one of the point coordinate is 0, 0, there you have to go with the second formula. If both coordinates are some other number other than 0 means, the first formula we can use. The next concept is section formula. So suppose line segment AB divided by some other point in a particular ratio. Then using this formula we can find the coordinates of the point of division. That means which point is dividing the line segment. That point coordinates x and y we can find using this formula. This is known as section formula. Suppose the dividing point AB is a line segment, P is another point which is dividing the line segment in a particular ratio. Sometimes the dividing point may be the midpoint of the line segment. That time you have to use this second one. Look at the fourth point. This formula you have to use x1 plus x2 by 2, y1 plus y2 by 2. Generally section formula means, in this third point they have given no, that is called as section formula. m1x2 plus m2x1 by m1 plus m2, m1y2 plus m2y1 by m1 plus m2. Okay children, are you clear? So both distance and section formula I will derive. Derivations are there for distance and section formula. After I will complete the sums, let me derive at last this both formula. Okay. Now there are only two exercises we are going to learn. One is distance, another one is section formula. Distance formula we are going to use to find the distance between the two line segment. Section formula, if one point is dividing another 2 points, that means line segment. The line segment joining the 2 points in a particular ratio, what is the coordinate of that point? For that we are going to use section formula. Am I clear? These two are the concept, only two exercise in this chapter. Now we are going to revise, we are going to see the first exercise. Okay? Yes. (7.3), 7.4 also not needed because that is optional exercise. It is based on the centroid. That concept also removed. So third 7.3 exercise area of the triangle and 7.4 not in the syllabus. Only the first two exercise we are going to see. Okay, now look at the first question. Find the distance between the following pairs of points. There are three subdivisions. The first subdivision 2, 3, 4, 1. First we will see the first subdivision. So first subdivision, first 2, 3 and 4, 1 means you know very well always the first point is the x coordinate and the second point is called y coordinate. Okay. So 2, 3 means x1 2, y1 3. In that 4 comma 1, x2 4, y2 1. That you have to mark it first. First you have to write that one, which is x1, x2, y1, y2. Then that x2, x1, y2, y1 value, if we apply in the distance formula, we will get the result. For example, x2 here 4. So 4 minus x1 2. 4 minus 2 the whole square. The same way, y2 1, y1 3, 1 minus 3 the whole square. 4 minus 2 square also 2. 1 minus 3 all square is minus 2. Anyways, while squaring 2 and minus 2, we are going to get the same result, 4 only. So 4 plus 4, 8. 8 can be written as, root 8 can be written as 2 root 2 units. So the distance between the 2 points 2 comma 3 and 4 comma 1 is nothing but 2 root 2 units. Okay, distance between these 2 points is 2 root 2 units. That is why I have said the distance formula can be written as both ways. For example, now we have applied x2 minus x1 the whole square. Suppose you just have a try. You find in this another way. I think I said no already while explaining the formula. That way you try. What will come? First x1 2, x2 4. What is 2 minus 4? 2 minus 4 minus 2. While squaring minus 2, what you will get? 4. The same way y1 minus y2. 3 minus 1 plus 2. 2 square 4. The same answer only you will get. So that formula, however you will write, you will get the same answer. Out of the two ways, you can use any one way. Okay, the same method we have to use for the second and third sum. Look at the second sum. The coordinates are minus 5, comma 7. x1 minus 5, y1 7. Minus 1, comma 3. x2 minus 1, y2 3. Just apply it. x2 minus x1 minus 1 minus of minus 5. Already in formula 1 minus is there. Now for the x1 coordinate minus 5. So minus of minus should come. You have to apply this carefully. Whenever you are getting minus of minus, if you multiply 2 minus, automatically it will change to plus. So 1 plus 5 is nothing but 4. 4 square. Likewise, y2 minus y1, 3 minus 7 the whole square, that is minus 4 the whole square. 16 plus 16 will come. So root of 32. 32 also is not a perfect square. So 32 also we can write as 4 root 2 units. How can we write the 32? 4 root 2. Suppose if you split 32 2 into 16, then for 16 is a perfect square, so that the square root of 16 4 that can be taken outside, inside will be root 2. So 4 root 2 units. That units is very important, because suppose whenever we are writing the line segment length, how we will write? In construction chapter also we have learned. Suppose let us draw AB line segment equal to 7 centimeter, or some unit we used to denote always. So here generally that centimeter or meter, here they didn't give, so that generally we should write units. In the answer step you have to write the distance between minus 5 comma 7 and minus 1 comma 3 is equal to 4 root 2 units. This is how your answer step should be. Okay? Yes. Now look at the last subdivision, children, in first question. It's not a number, it's a variable. A comma b and minus a comma minus b. Whether it may be variable or number, rules is same only. The same rules we are going to apply. Write the formula and substitute. Minus a root of minus a the whole square. Minus a is equal to minus 2a. Minus 2a the whole square. The same way minus b If say both has same sign mean we have to put addition, we have to do addition and we should put the same sign. Using that minus 2b the whole square plus minus 2a the whole square will come. While squaring, negative also will change to positive. Minus 2a square is equal to 4a square. Minus 2b the whole square also 4b square. Commonly 4 is there for both the term. Common number is 4. That can be taken outside. So 4 into a square plus b square. Square root of 4, 2. But a square plus b square, what is the square root? We don't know. We should not write a plus b. A plus b is not a square root of a square plus b square. So let it be inside of the square root itself. Only for 4 we can take the square root. So the answer is 2 root of a square plus b square units. Okay, units. Now coming to the second question, find the distance between the points 0, 0. So one of the point is the origin means, then we can go with the second formula. While explaining the formula I said no, the second one, root of x square plus y square. Excuse me. Okay children, now we will see the second sum. So this is the second question. When you see if one point coordinates are 0, 0 like this. Suppose here the coordinates of the first point is 0, 0 and second coordinate is x coordinate 36, y coordinate 15. That time we can use the second formula. The formula is distance is equal to root of x square plus y square. How we are using this formula x square plus y square? Why? Because 0 minus 36, what will come? The same number. From 0, if we subtract any number, the same number only we will get. Or from the number, but in the negative sign. 0 minus 36 means minus 36. 0 minus 15, minus 15. Suppose from 36 you are subtracting 0. 36 minus 0, 36 plus 36 and 15 minus 0, 15. However, whether it is minus 36 or plus 36, while squaring we are going to get a same answer, isn't it? So that instead of that distance formula, we can use this one. But you can ask a question, why ma'am, suppose if we will use distance formula, any changes will happen? Certainly not. You will get the same answer. Whether if you go with this formula root of x square plus y square, or suppose if you use the distance formula, the same answer only you will get for this question. But this is easy. While seeing the formula itself, you can understand. Instead of x2 minus x1 the whole square, if we write x square, that is easy only, no? So this is easier than the first one. So this is applicable only if one of the coordinates are 0, 0. Only for these kind of sums you have to apply. Suppose I am giving one point. I am asking you to find the distance between 2, 3 and 4, 5. That time you can't use this formula. For this formula is not valid. Only whenever you are getting 0 as one of the coordinates, there you can go with this formula. Okay. Suppose one another example I am saying. Another point, if it is 0, minus 6, this is coordinates of A and coordinates of B 3, 5. Suppose I am asking you to find the distance between these two points. Also, you should not use this formula. You have to go with the first distance formula only. Am I clear, children? So, whenever you are getting both x coordinate as well as y coordinate is 0, that time alone you can use this formula. Otherwise, You have to use distance formula only. Okay. Now we will see. So here you can take x as 36. So x square 36 the whole square plus y square 15 the whole square. Square root inside the square root only. So what is 36 square? 36 into 36, 1296. 15 square, 225. Here no place, so let me write down. So 225. Don't get confusion, 225. If you add these two numbers, 1296 plus 225, you will get 1521. 1521. What is the square root of this 1521? I don't know how to find the square root for if the numbers are large number. Up to 3 digit you will say easily. If I ask what is square root of 400, you will say. But if it is 4 digit number like this, 1525, use long division. Find the square root. Okay. Now see. Let me teach how to find the square root for this. So first 1521. You can write, put bar, make a group. So here 15 one group, 21 one group. First for 15, which is the nearest square root number, 3 and 3. 3 3s are, so let me write here 3 and 3. 3 3s are 9. If you take 4 4s, then it will exceed. 4 4s are 16. What's the remainder? 15 minus 9, 6. Okay. Take the next group. Only group you can take down. You should not take single number. You have to take the second group. Now 621. This is the quotient. This quotient should be doubled now. Doubled means we should multiply by 2. 3 2s are 6. So here and here one number we have to write that should satisfy 621. It can be closer to 621 or less than that. Okay. If you find, you can use just a trial and error method. You can use first 8 9 like that. If you use 9, it will satisfy. 69 into 9 is equal to 621. Exactly you will get. So now look at the quotient. This quotient is a square root of this number. 1521 is equal to 39. Square root of 1521 is equal to 39. Therefore final answer is this. This is the rough work. You should do this long division in your rough column. So this is equal to, answer equal to 39 units. You should write distance between the 2 points is 39 units. The point 0, 0 and 36, 15. Can you understand, children? So there are two formulas today you have to keep in your mind to find the distance. When you have to use the first formula, when you have to use the second formula, that you have to understand. Out of the two, there are always you will get 2 points and its coordinates. One of the point coordinates are 0, 0. Means you can use the second one. Otherwise, the first one normally for all the sums you have to use. Let me say the formula finally. Distance. To find the distance between any 2 points, the distance can be calculated. If the coordinates are x1, y1 and x2, y2 means root of x2 minus x1 the whole square plus y2 minus y1 the whole square. If one of the coordinates is origin mean, then the formula will change to x square plus y square. Okay, revise the two formula, children. Thank you so much.